2.
Okay. What are the instructions? Graph it?
It says graph the system of inequalities and then include all work.
Include what? All work? Okay.
Yeah, so just graph.
Okay. So, tell me which one to begin with. It's the easiest one to graph.
The bottom.
Okay. What's the bottom look like?
So would it be -4? That's where you'd plot your on the y.
The vertex. Okay. What is this? What kind of shape is this? It's not a straight line. Straight lines only have x. The first inequality is a straight line. But this one is not. This is quadratic. What do quadratics look like?
They look like
All of them.
okay.
Called parabolas. So, is this a parabola that opens up or down?
It's gonna open up.
Okay. It's going to be a dotted line or a solid line. These are all the questions. Yeah, you got to answer each of these questions really before I draw anything, because it's hard to turn a solid line into a dotted. But
it's gonna be solid.
Okay. And do I know where the x-intercepts are? And the way you solve it is you solve this. Because remember, y is always 0 when you're on the x-intercepts. So solve that equation for x.
Okay.
What is x equal to? If x squared minus 4 equals 0, what is x equal to?
2.
Plus or minus 2?
Plus or minus 2.
Remember that, plus or minus. If you forget that plus and minus, you will definitely lose credit on any test. There's no way a teacher gives you full credit if you leave off the plus or minus. And in this case, it makes sense. I should have an intercept there and another one there. And I have a parabola that looks like this. 3 points determine a parabola. We've got the vertex, and we've got the 2 intercepts. So there's our parabola. Now, am I above or below that? And that's always the question you want to ask. You never want to answer, am I to the right of that or to the left of that? No matter what the shape of the thing you've drawn on there, unless it is a vertical line, then you want to say above or below. If it is a vertical line, then you have to say either right or left. But if it's anything other than a vertical line, you always want to look at it from an above or below perspective. So what is it here?
Would it be above?
Correct, because of that. That's the only part you look at. Y is greater than. So we're shading this part. Let me do it like this. All right. What's the next thing we should graph? Or the other thing? How do I graph the other thing? This part.
Well,
that's a straight line.
Yeah.
So what do we start?
Do you graph the 3 first?
So we'll put that's at 3. And then
up 1 over 2.
Over isn't specific enough.
Oh, okay. Up 1 over to the right.
Yeah. Notice that if I go up 1 and over to the left, that's not correct.
Yeah.
So over doesn't distinguish between right and left. So I definitely have to go to the right. And the easiest way to remember it is just make sure when you're done you have a positive slope. Is this a dotted
Yeah.
line or a solid line?
It's going to be dotted.
And am I above or below that?
Below.
So I'm this way. And that gives us a common area of that. What else did they want? Is that good enough?
Yeah, that's all they wanted.
Okay. That's probably a really good way to do it, exactly as I did it. You don't need to make these arrows so long, just so long as, I used to shade the whole thing, and then I realized it's harder to see. If you've
Yeah.
got a bunch of cross lines, it's harder to see the area that is the common area. Now, let me ask one last thing. Is this point in the region?
Yep.
Is this point?
No.
Is this point?
No.
Yes. If it's on the dot, if it's on a solid line, it is.
Oh, okay, yeah.
Is this point?
No.
Because it's on the dotted line. So
Yeah.
it either has to be inside or on a solid edge. That's the only points that are in the region. Okay. Let's do number 3. You pick.
Let's do the top one.
Okay, how do I graph that?
Would you reduce it first?
Correct. Go ahead.
So it'd be 2x minus y is greater than or equal to minus 4.
Okay, I don't particularly like that step, but that's okay. It'll get us there. Now what?
Um,
In other words, you still can't graph that.
do you have to switch the y and the...
You got to put it into y equal mx plus b format, right?
So,
In other words,
yeah,
you could actually graph this. There is a way, a relatively easy way to graph this. The problem is you don't know whether you're going to shade above or below it after you graph it.
yeah,
So the only way to know that is if we solve this for y. Once we have y completely on itself, like over here, when y is to the left, totally alone, then whenever you graph your line, you know which side to shade.
yeah,
So we don't know until we get this into y is greater than or equal or something and have everything else on the other side.
okay.
Next,
So, so add 4 on both sides, and then, and that would get you to 2, and then you have to add y.
okay, I'm going to show you what might cause some confusion if we do that. That's actually pretty good, but it's not what we're used to looking at. We're used to having the y on the left.
Yeah,
Now, if it's an equation, it doesn't really matter whether the y is on the left or the right. But if it's an inequality, go ahead and finish this.
um,
How do I graph
so you,
that?
So
I
you'd
now
put the
have it. I actually now do have it in y equals mx plus b format.
yeah. So you add the 4, so put it on the 4, and then do you go up 1 over 2?
It's rise over run.
Okay, so up 2 over 1.
Over which
And go right, right.
dotted line, solid line.
Solid.
Above or below?
Um, it would be it'd be below.
That's pretty good. How certain are you?
Well, I'm kind of confused because the y's on the other side.
Exactly. That's why I don't like doing it this way. You're actually right. It is below. Because y, one way to look at this, even if y is on the right side, a way to look at it is y is less than this line. So I got to be under that line.
Yeah.
So I can do it this way. It's just I don't like inequalities where the y is on the right side. It tends to confuse people. So let's do it in blue the correct way. If I've got 2x minus y is, in other words, the correct way I mean by leaving the y on the left.
Okay.
Tell me what the next line is.
So minus 2x. Oh no, it'd be y
Where are you getting
is
y?
also minus y.
Yeah, the next line is to subtract 2x from both sides, correct?
Yeah. Yeah.
When I take away 2x, I don't get rid of this negative sign.
Okay.
Okay, so that's still there. And very important, you cannot drop negative signs. If you drop even one negative sign, you're missing a problem. Okay?
Yeah.
I mean, and everybody, that seems to be the most common mistake. People really want to drop negative signs. They don't like them. The sooner they can get rid of them, the better. Now what? In other words, I still don't have y. I got a negative y.
Um,
How do I
you
get
have to
rid of the negative sign?
add y.
No, that'll make it 0.
Um,
And if I
add
add
2.
2y, then I'm going to have a 2y on the other side. I haven't solved something until I get y on one side alone and not anywhere else.
Okay.
So how can I leave y on the left side and get rid of the negative sign?
Um, add 1.
Divide by -1.
Okay.
Right now, I don't know. I'm beginning to think math shouldn't do this. Math should not allow an implied 1. Because if a person doesn't see it, they don't realize it's there. That's actually negative y means -1y. If I wrote it like that, you'd be more likely to figure out that you got to divide both sides by -1, right?
Yeah.
Okay. What's the next line?
So y is greater than or equal to um 2x plus 4.
The only difference in an inequality and an equation is when you divide both sides by a negative number or multiply both sides by a negative number, you have to switch the direction of the inequality. So it becomes that, not greater than or equal, but less than or equal. I still
Wait,
divided every term by -1. I also have to switch the inequality.
okay.
Okay?
Is that only when you divide by a negative?
Divide or multiply.
Okay.
Not add or subtract. You do not have to do it for any addition or subtraction. But dividing or multiplying, yes. Now, notice that actually is the same as that.
Yeah.
Y is less than this line. Over here, if I start with the Y, I'll say Y is less than that line. I just kind of have to look at it from right to left instead of left to right. So, I don't know. There's an advantage to doing it the first way, which is I don't have to deal with that dividing both sides by a negative number. In other words, I never had to switch the direction of the inequality sign. And I did have to do that in the blue method. The advantage of the blue method is it gets our y on the left side where we know how to interpret it perfectly. I know what that means. I'm not 1,000% sure what this means up here.
Yeah.
Even though I am, it's just I'm not used to it. So it's easy to make a mistake. So I don't know. I'll leave you both solutions and you can figure out which one to do. Math is very frequently, there's 4 different ways to do any problem. And some people might think that you would confuse somebody by showing them all 4 ways. I happen to believe I'm on the other camp where I think you increase understanding of the problem by showing a person multiple ways to do it. All right, so now we got to graph this one. Whoops. What is that? What shape?
That would be a parabola.
Okay, where's the vertex of that parabola?
At -8.
No, we're talking about the second one.
Oh, -2.
Vertex is an x and a y coordinate.
Oh, so -2 and 1.
No, here's the standard format for vertex format for a parabola. H and K are the x and y coordinates of the vertex. That's why this is such a great format. If you can take a quadratic and get it into this format, then you're staring right at the vertex. You don't have to do any math at all to figure out where the vertex is. Where is it with this one?
It would be
H is the x coordinate, K is the y coordinate.
-1 and 2.
What's H?
H is -1.
Well, if H were -1, then I would have x minus a -1, and I would be staring at x plus 1. I'm not.
All right.
I'm staring at x minus 1. So what is H?
It's 1.
Okay. And at this level of math, it is always x minus h and y minus k. Always. It's never x plus h. It's not even ever y plus k. Notice that that k started out on the other side where it was y minus k. And then we brought it over to the right side, and that's what turned it plus. But whenever you have x combined with h, it's always x minus h. So our vertex is at 1, -2. That is about right there. Do I open up or down?
You open up.
Because A is what in this case?
A is just 1.
Yeah, it's positive. That's the most important thing.
Yeah.
It's positive, and that's why it opens up. Okay. Now, show all work. I can't graph this parabola unless I have two other points. It's the best way to get two more points. In other words, because she said show all your work, I can't just graph a parabola using that as the vertex. That's not going to give me the right width of that parabola. But if I can get two other points, now there's two choices for getting two other points. I can get the x-intercepts, in other words, where this parabola is going to cross the x-axis, or I can figure out the y-intercept really easily. And once I get the y-intercept, then I'm going to be able to go a symmetrical amount to the right to figure out the other intercept. Which do you think's easier?
Probably the y.
I agree. How do I get the y-intercept?
Um,
What's x when you're on the y-intercept?
it's 0.
Okay, so plug 0 in for x and do the math. What is y equal to? Now understand this, that we're graphing this based on an equation. We're not worrying about the inequality yet. I've got to figure out where the graph goes. Then I'll worry about which side to shade. But you always start these things off by treating them as equations first in order to graph them. So if I'm solving this, y equals 0 minus 1 squared minus 2, what is that?
It'd be -1.
Okay, so there's -1. Now hold on, actually let's put -1 right about there. Now the coordinates on that point are what?
1 and -0. One, no, sorry, -1 and 0.
No, first coordinate's always the x coordinate.
So 0 and -1.
So I know that there's some point right there, right?
Yep.
In other words, wherever this y-intercept is, there has to be a symmetrical point on the other side. And now I have 3 points. Now, just for the heck of it, what is the coordinates of that point? If we're really trying to show the teacher we know what we're doing. What's the
2,
y-coordinate of it?
it'd be -1
Okay, good.
and 2.
Correct. In other words, I know I'm the same amount of distance from the vertex, only on the other side. So this one was 1 to the left of the vertex. This point has to be 1 to the right of the vertex.
Yeah.
So now we've drawn it correctly. Which side do I shade? Because it's not that, it's this.
It'd be below.
Is a dotted line or a solid line?
It would be dotted.
Forgot to ask when I was doing it. Okay. And which side do I shade?
Below.
What's that say?
Oh, it'd be above.
That's the only part you ever look at. You don't look at anything to the right of that. If that says y greater than, it's always above. If that says y less than, it's always below.
Yeah.
Okay. So we're going to shade this part. What happened to our other line? We decided we were shading below it, right?
Yeah.
Whoops. And again, I am never saying I'm going to shade to the right of the red line. That's not the terminology you want to use. It's not right or left. It's always above or below. So, read the instructions again for these two problems.
Just graph the systems of inequalities.
Okay. Can you see what the problem is here? If I try to shade the common region, it appears that it goes on forever.
Yeah.
And it doesn't. What happens is, had I drawn this thing not approximating it like I did, if I'd have drawn it on a grid sheet, then this red line is going to intersect again with that blue line. And so that, you know what I'm saying? In other words,
Yeah.
let's change the slope on the red line just a little bit. Let's see if I can do it without wiping out everything. I don't have to change it much. And now the blue line intersects in two spots. And we don't have any of that. And our common region is just the green that is in between the blue and the red. That's almost always the case when they give you a problem like that. It's very rare that your shaded region is an infinite region. It's almost always a finite. In other words, it's surrounded by all sides. The way I had drawn it originally, it was an infinite region. It did not appear that the parabola ever crossed the red line on the right side.
Yeah.
So it would have gone on for infinity. Not that there's anything wrong with that. I can think of some slopes of this red line where that would be true. It would not cross it on the right side. You know, I mean, I don't need to make that slope much steeper. If I make that red line like this, then the blue line's never crossing the red line up top. It'll cross it down there, but never again, because the blue line keeps going that direction and the red line keeps going that direction, so that never crosses. So it doesn't always cross twice, but on these problems that they're giving you, I would say that 99% of the times it's going to cross twice. Although I think we did one yesterday where we had an infinite region. And I was puzzled. In fact, I might have said at the time, I think this is a typo because they never do that.
Yeah.
All right, number 4 next.
Yep.
What do I use on number 4? The law of cosines or the law of sines to start out?
Cosines.
Good. What two types of triangles do you have to use the law of cosines? One is where you have side, side, side. That's what we're looking at here.
Yeah.
There's one other type.
Side angle side?
Yes. Both of those, you have to begin using the law of cosines. Because neither one of them give you that vital thing that the law of sines requires, which is one side and an opposite angle. If I have one side and its opposite angle, then I can use the law of sines to finish solving the whole triangle. But when you have side, 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 or side, angle, side, you don't have that. You do not
Yep.
have one side and its opposite angle in either situation. So let's go ahead and draw a picture here. Let's see, we got the smallest is C, that's 15. The longest is B, and that's 24. So I'm going to put the capital B there. And this side is 18, so the capital A goes there. So there's my picture.
Yep.
Now, to use the law of cosines, I need the general formula, and tell me how to apply it. First of all, give me the formula.
So a squared equals b squared plus c squared, and then plus 2ab,
Plus or is it minus?
oh, minus 2ab,
It's
and
actually
then,
2, and the 2 letters that go there are the same 2 letters that are over there already.
oh, bc, yeah, yeah. 2bc, and then cosine a.
Correct. This is always the same letter as is on the left side. And
Yep.
it's important to understand that capital letters are angles, little letters are side lengths. So this A is not the same as this A, but that angle is opposite that side. In other words, the capital A angle is opposite the little a side. Now, do you have to use this one, or could I have used b squared equals, in other words, let me just write a couple other ones here. This is also the law of cosines, right?
Yep.
In other words, there's 3 of them. And the third one, and you can see the pattern. Pattern is the same. Whatever letter is on the left, you use the other 2 letters on the right until you get to the cosine, and then use the same letter. So, is there a reason you chose that one?
No.
Could we
I
have
just,
chosen the other 2? Either one of them?
yeah, yes.
Yeah, only when you have side angle or side, side, side can you do that. When you
Yeah.
have a side angle side, you don't have any choices. You're stuck with choosing the one you have to figure out, which is the angle of the, you got to figure out one of the angles. So you have a choice between 2, I guess. But always know that all 3 of these are valid, and it just depends on which side you're trying to solve for. So there's nothing wrong with solving for A first. Let's do it. Help me.
Yeah.
First thing
So,
to do is just always plug in. Never try
yeah.
to solve this as you're going along.
Yep. So a squared, so 18 squared would be
Get your
324.
calculator. Okay.
Yeah.
Here, I tell you what. All right. We'll do it that way.
And then equals, so then 24. I got 801 when I added both B and C together.
Okay.
After, and then minus 720, and then cosine
Next step.
A. Now do you subtract the 801 from both sides?
Correct. What's that give you?
Um, so on the left side, it would be negative 477
Equals what?
equals minus 700. It would be gone, right? So then minus 720 cosine 8.
Uh-huh. Just want to make sure you didn't drop that negative sign.
Yeah.
Okay. Now what?
Now,
We're trying to solve for angle A. So we have
yeah.
to keep getting rid of everything else. In other words, our final answer is going to be A equals.
So do we get rid of the 720 now?
Tell me how.
You divide, correct?
By what?
477 or 720?
By negative 720. You
Yeah.
got to get rid of that negative sign also. You can't just get rid of the 720, otherwise we'll still have a negative sign in front of our cosine.
Yeah.
So I got to divide both sides by minus 720. Now I get what's left on, what do I have? Use your calculator to give me some numbers here. And do the intermediate step. Don't give me just A equals. Give me cosine of A equals.
All right, so negative
Not
0.6625.
negative. When you divide a negative by a negative, you get a positive.
Oh, yeah, yeah.
So
All right, so 0.6625 is equal to cosine A.
okay. So far, so good. Now, how do we solve for A?
Do we do the negative? You put into the negative cosine?
It's not negative cosine, it's the inverse cosine.
Inverse.
Yeah.
Inverse.
Or arc. There's two ways to talk about it. It's the arc cosine or the inverse cosine.
Yeah.
So what's the inverse cosine of that number?
48.5091.
Is your calculator in degrees?
Yeah.
5091?
Yep.
So it says round both sides and angles to the nearest tenth. Should we do that now or at the end?
You do it now, I think.
No, you want to do it at the end. If we do it now, we're going to accumulate round-off error. And when you accumulate round-off error through multiple steps, and we've got a lot more steps to go here, we're not done.
Yeah.
Nowhere near done, is all we're doing is solving for angle A. We still got to solve for angle B and then angle C. So we got multiple steps here. So if I round off here, it's going to affect all the other answers. So I want to, if I need to eventually round it off to the nearest tenth, I'm going to put at least 2 decimal places there.
Yep.
0.509, is that what it was?
Yeah.
Okay. So that's my angle, 48.509 degrees. So up here I got 48, and you'll see why this matters. What if I'd have gotten this? What if I'd have gotten the cosine of A equals 1.1? What would that mean?
Would your calculator be in the wrong mode?
Cosine can never be greater than 1 or less than negative 1.
Oh, okay, yeah.
If you're solving using either the law of sines or the law of cosines, and you get to a point where it says either the sine or the cosine of an angle is outside of that range, then it means it's an impossible triangle.
Okay.
This cannot be. The cosine of A can never be greater than 1 or less than minus 1. So a lot of times you will discover that you're looking at an impossible triangle because you get to that step and it tells you, it gives you some answer that's not less than 1. Now, they're not doing that to you. I just wanted to point it out so that if they do it to you, you'll be able to figure it out, spot it. Okay, so we got 4 of the 6 parts of this triangle solved for. Now what?
Now you do the law of sines for.
Correct. Let me erase all this. Give me the general law of sines.
Sine of, is it big A? Sine of big A?
You always take trig functions of angles. You never take trig functions of sides.
Okay. Over A is equal to sine of big B over small b.
Also this. This is actually the general. They're all the same ratio.
Yeah.
Okay. So apply this, and incidentally, it also works in reciprocal. In other words, A over the sine of A is equal to little b over the sine of big B. In other words, I can flip everything as long as I flip them both. I can't flip just one of them. You know what I'm saying?
Yeah.
It's a subtle thing. Every now and then it'll be a little easier if you do flip it. But just know that you can do it. It's just as valid if I flip it. Okay, so what's my next step?
So now it would be, you'd plug, so it'd be sine of 48.509 over 18 is then equal to sine of 24 over small b.
You don't take trig functions of numbers. You take trig functions of angles.
Oh yeah, yeah. So sine of b over 24.
Next step.
Now do you have to, this is the part which kind of confuses me.
Well, what am I solving for?
B.
Okay, so what do I have to isolate first?
Oh, B. So you have to, do you have to multiply the other side by 24 or both sides by 24?
Good. Gets rid of that. Now turn that into a number for me. It's 24 times the sine of 48.509 all divided by 18.
Is 0.9987.
Really?
Yeah.
Seriously close to being over 1. Again, had that been 1.01, I would have said you cannot have a triangle that has these 3 sides on it.
Yeah.
In other words, if that 24 side was 240, that's an impossible triangle. You can't have a 15, 18, 240 triangle. And you would discover it by when you go to solve it, you'll find that the sine, some cosine or sine will be a number greater than 1. In this case, that's awfully strange. No, it's not that strange at all. Okay, so tell me what B is.
Do you do the inverse for this one?
Always.
Okay.
You take, here's the thing you got to know, and this is extremely important. You take trig functions of angles to get ratios. You take inverse trig functions of ratios to get angles. Now,
Yeah.
we're not looking at a ratio here, we're looking at a decimal, but you know what I mean. Normal trig functions, you have ratios when you're dealing with right angle trig functions. we would have a ratio, but we've represented it as a decimal. So if I'm solving for angle B, I've got to take the inverse sign of that number.
Okay.
What is it?
87.0781.
0781?
Yeah.
Okay, and that's B. 87.079. And now you should kind of be able to see why we didn't want to round off early.
Yeah.
Because if I'd have rounded off early to what they request, to the nearest tenth, well, I would have lost this 0.09 here. And that might have affected this answer slightly. Just enough where it would change the final outcome by 1/10. And I might end up off by 1/10.
Yeah.
That's why you don't want to round off early. Now, there's a sixth part to this triangle we haven't solved. How do we get angle C?
You add A and B. You subtract them both from 180.
Do that. Add those two numbers, subtract from 180, and tell me what you get.
With all the decimals at the end?
Again, you don't want to create round off error. So for now, yes. We'll get to that. Best way to do it is go ahead and add those two numbers, and then just put in minus 180, and it'll give you the correct number.
43.70.
43.70 what?
99.
Okay, now we're ready to give an answer. This is not the answer because we haven't rounded everything off. So what is angle A equal to?
48.50.
Just 0.5. You're rounding it off to the nearest tenth. That's only one spot to the right of the decimal place. You don't want to put the 0 in there. If you put the 0 in there, you're kind of indicating that you're rounding off to the nearest hundredth. And since they gave us explicit instructions, we want to follow them. What is angle B?
87.1.
And what is angle C?
43.7.
Okay. And now we're sure that we don't have any accumulated round-off error. And you might say, well, there's more decimals to the right of each of these. And that's true, but they're so far away from the 10th spot that we don't need to worry. We might have a tiny bit of round-off error, but it's going to be in the hundredths position because we took each of these numbers out to the thousandths spot.
Yeah.
If we'd have rounded it off early, we could have ended up with an answer like 48.5 and then maybe 87.2 and then maybe 43.6. In other words, we could have actually ended up being off by a tenth on some of these.
Okay.
Okay, so that's why you don't round off early ever. And if you're doing it on a calculator, you don't even need to round off to 3 decimal points like we did. You could just leave whatever number it is on the calculator in there for the next step. And then you'll be absolutely certain of not having round off error. And then there's no need to round off the side. Well, they gave us all 3 sides anyway. So the only thing we were solving for is the 3 angles.
Yep.
Okay. What kind of triangle is number 5?
Side angle side.
So what are we going to do here? Give me the equation I'm going to use.
You're going to use...
Let's draw the picture first. I'll try to draw it reasonably accurate. In other words, I want a 110-degree angle there. And that's B. And then little a, let's see, if I make that angle A, then little a has to be that side, and that's going to be C, and little c is that side. So there's my diagram. Again, I cannot use law of sines because I do not have an angle and its opposite side. I don't know the two angles opposite the two known sides, and I don't know the side opposite the only known angle. So again, I got to use law of cosines. Tell me how to write it.
So you'd use the b squared
Yeah, it's
equation.
a little helpful to go ahead and put little b opposite the angle that we know.
Yeah. So b squared is equal to a squared plus c squared.
Okay, go ahead and start filling in those numbers for me.
Oh, okay.
Don't do it on your calculator. Let's just write it. In other words, I'm going to write 14 squared. Go ahead.
Plus 32 squared, and then minus 2 times 14 times 32, and then cosine b.
No. Cosine of what? What's b?
Big B?
Yeah, we know that. They gave it to us. So it's cosine of 110.
Oh, okay, yeah.
Okay. You always want to end up with only one unknown.
Yep.
And we've got it. It's little b. So everything on the right side of the equation is just a number.
Yep.
And I really think it's important when you do math to do it this way. I think it's a mistake to go ahead and square 14 and start doing the simplification before you have finished writing it out. That is a recipe for mistakes. Now you can even do it one step at a time. Let's just keep going. Now use your calculator and let's start doing it.
So b equals 1,220.
Is that the sum of them or each?
That's the sum of, that's both of them.
1,220?
Yep.
Okay.
And then 800 minus 896, and then cosine 110.
Well, what's that number?
Huh?
What do you get? What's your calculator say?
Do you just put that into the calculator like that?
Cosine of 110.
Oh, okay, yeah. Uh, 0.342.
No. Cosine is negative in the second quadrant. That's a second quadrant angle.
Negative 0.3420.
Does your calculator say negative?
Yeah.
Good. Okay. Again, do not drop negative signs. What is it?
Negative 0.3420.
Okay. Now, turn all of that into one number.
So,
Are you on an Inspire or a TI-84?
TI-84. I'm just confused how to just put it in straight like that.
Well, the TI-84 is harder. I want to be more specific here. So I multiply that times that immediately. What does that give you?
It didn't work.
Do 0.342 times 896. Forget the negative sign for the moment. Just multiply the numbers.
306.432.
Now, I got a negative sign there, I got a negative sign there. So I know those two negative signs are going to turn to a positive. So I know it's 1220 plus that number.
So 1,526.432.
Now, what's B?
So
You can take that answer and hit your square root key.
yeah.
So you don't have to retype the number.
39.069.
So what is B going to be equal to?
Huh?
Since B is the first thing we solved for, let's go ahead and round it off to the nearest tenth.
So 39.1.
Now what do we do?
Now you can just add both of the angles.
No, we have all three sides and we have one angle, but we're still missing two angles. We're missing angle A and angle C.
Do you do the law of sines now?
Always. Whenever you start a problem with the law of cosines, the next step is always the law of sines. Because it's all the law of cosines gets you is the piece that you're missing in order to use the law of sines, which is that relationship. Well, we now have it. So I'm going to speed things up here because I have a 5:30 I got to go to, but I want to be specific here. Here's what I'm going to put in. I'm going to not put 39.1 in. That's what happens when you try to hurry. It's the sine of 110 divided by 39.069 equals what? No, I don't want that number. I want the rest of the equation on the other side.
Oh, okay. Sine of A.
You can do either one.
And then over 32.
Now, that's a known, that's a known, and that's a known. So we're going to be able to solve for A here.
Yeah.
Okay. Once we solve for A, how do I get C?
You can just add them all together.
Correct. And that's always the last step. Whenever your first step is using the law of cosines, your second step is the law of sines, and your last step is using the fact that all three angles have to add to 180.
Yeah.
And those are two actually pretty good problems because you have to use both the law of cosines and the law of sines to solve them. All right, Lachlan, I will let you go. And,
Thank you.
Talk to you next time. Good night. Bye-bye.